Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now, back to the show. Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers, because once we do, we'll be able to put a donate button, and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD, and working on a product to help people overcome these problems, because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius podcast
with Richard Jacobs.
This is Richard Jacobs with the Finding Genius podcast, now part of the Finding Genius Foundation. I have Dr. Moray Campbell. We're going to talk about the role of vitamin D in prostate cancer and how vitamin D affects the body. So welcome, Dr. Campbell, but I'll call you Murray if that's okay.
That's great, and I'm very grateful for the invitation to be here.
Yeah, I just have a minimal bio. I see that you're a research scientist at Cedars-Sinai Cancer Center, but please give me a bit of background on yourself, and then we'll talk about your work with vitamin D.
Yeah, sure. So I'm a cancer researcher, and I did my sort of undergraduate and graduate training in the UK, some training in the US, and then back to the UK. I guess I've, like a lot of scientists, you tend to have you're fortunate enough to have experience in different countries. But I've been in the US since 2007, worked at a couple of institutions, and then just moved to Cedars at the beginning of this year. Yeah.
Okay. How did you get involved with vitamin D?
Yeah, so it actually goes back to my postdoctoral training. So that's, after you do a PhD and do some more research experience. And I joined a group, ironically, at Cedars-Sinai. So it's my second time at Cedars-Sinai. So this is in the mid-70s, mid-70s. It feels like it. No, it was in the mid-90s. And I joined a group there, and they were interested in nuclear receptor signaling and cancer. And vitamin D receptors are a member of the superfamily of human nuclear receptors, which are transcription factors. And so that was the work that was going on in the lab. And so obviously I got involved in that. And then, inevitably that inevitably sort of pushes your career off in a direction. So rather unwittingly, you end up going down the route often of directions that were determined at quite a sort of junior stage in your career, because you generate momentum in it. So that's how it started. Why? Maybe just for background, why people are interested in nuclear receptors and cancer. Earlier than that, in the 80s, there had been an idea that you could activate certain transcription factors and induce differentiation in a tumor, and so that you could control the tumor by controlling its growth and making it a sort of a differentiated, less aggressive phenotype. And that actually proved to be very successful in certain leukemias. And some of the agents that were doing that in the leukemia arena were ligands that bound to nuclear receptors. So the retinoic acid receptors, and they were bound by retinoid compounds And so the vitamin D receptors in the same class of transcription factors. And so there was an idea that various cancers could perhaps be controlled with vitamin D signaling. And, you know, that's the 1990s and perhaps into the early 2000s. And there was a lot of work, but actually those studies, I may be kind of jumping ahead to the punchline here, but those studies ultimately were pretty equivocal. So the cell biology is interesting. The molecular mechanisms from a scientific perspective are interesting, but the clinical trials were not successful. And so certainly in prostate cancer, there was a large clinical trial that ultimately failed. Our rationale for why then we would go back and revisit it was that probably the context of genomic ancestry hadn't been considered, i.e. those clinical trials were undertaken at North American institutions, and the majority of the men in those clinical trials we had European ancestry. And our rationale was that the vitamin D receptor plays perhaps a more pivotal role in prostate health and prostate cancer in men of African genomic ancestry than in European genomic ancestry. And so although the trial was, or that work was maybe aimed at an interesting question, potentially it was the wrong patient group it's directed at.
All right. So what are you studying in regards to vitamin D in cancer?
So we're interested in, from a genomic perspective, where the vitamin D receptor binds across the genome and how that varies by genomic ancestry. So whether someone has African or European genomic ancestry, I mean, that's where we started. Obviously, there's other genomic ancestry. So where it binds, what genes it regulates, and what those gene regulation scenarios do to both a non-malignant prostate cell and then what they would do to a prostate cancer cell.
Well, okay. So what does that mean? So people with certain background serum levels of vitamin D experience cancer in one way versus another? Like what kind of specifics were you able to draw from research?
Well, so from the research study we just published at the beginning of the year, we were able to show that the vitamin D receptor bound in distinct locations in prostate cells and prostate cancer cells that were derived from men of African genomic ancestry compared to cells derived from men of European genomic ancestry. So that's understanding where the vitamin D receptor binds in the genome and how that relates to gene expression. But we were also lucky enough, as with all these studies, there's a large number of authors on the paper because it needs so many different resources and insights to sort of pull these studies together. We were lucky enough to collaborate with different folks who had clinical cohorts of tumors from African American or European American men, and to look at gene expression profiles in those tumors and then relate those gene expression profiles in tumors to what we've been able to identify in cell line studies. And so we had reasonable confidence that what we were seeing in cell lines actually occurred in humans.
What are you seeing happen in the tumors and in the cell lines? What do you mean? Are you seeing like epigenetic changes that are correlated with, with cancers at certain stages, or what are you seeing?
Yeah, so the frequency and the significance of where the VDR seems to bind in African American prostate cancer cells is much greater than it is in European American prostate cancer cells. And then in those clinical cohorts we had access to, tumor gene expression profiles, we could see genes that we knew had identified in cell lines that were bound by the vitamin D receptor and regulated in African American cell lines. We could see those genes being regulated and related to serum vitamin D levels in African American patients. Couldn't see that in the European American patients. And I think that suggests that just the biology of the vitamin D receptor is more prominent in African American prostate cancer than it is in European American prostate cancer. And maybe that goes back to why the clinical trials were ultimately equivocal, because 99% of the men enrolled in, or I don't know that for sure. I don't know the genomic ancestry of the men who were enrolled in the clinical trial because I don't think it was reported at the time. It's probably fair to assume it was 90% European American men. And I think vitamin D receptor just has a less prominent role in the prostate, prostate health and prostate cancer of a European American man.
Okay, so what is the result of this research? keep vitamin D levels at certain levels, or I mean, what what did you find? That there was some correlation, but what did you find? How did it affect cancer?
Oh, so that then African American cells certainly are seem more responsive to vitamin D. So you could make an argument for saying that we should think more carefully about what's the appropriate level of the vitamin D receptor activation of vitamin D for health, and we should think about in the context of genomic ancestry. So at the moment, obviously, if you buy any product that has vitamin D in it, there's a sort of an RDA, isn't there? There's an amount of vitamin D that's recommended, and those levels are generated by panels of experts that consider all the literature and say, if you have less than however many thousand units a day, or whatever, you're at risk of bone fracture and those sorts of things. And I guess what our research is starting to suggest is perhaps you need to think about that not only in the context of, well, how much vitamin D do you need to prevent bone risk, because of course vitamin D plays this big role in calcium absorption, but how much do you need for this other side of its behavior, which seems to be controlling epithelial cell growth and differentiation, so prostate, but presumably mammary gland too, intestinal, etc. And then how much does that vary depending on the genomic ancestry of the individual? Is it, I guess our research is opening the question as to whether that's a different amount required for, in the case of prostate, men of European versus African genomic ancestry.
What does that mean? Do they have to have a certain level of vitamin D in their serum, or what's the practical application of this? Or it's not there yet? You haven't been able to.
Yeah, it's not for me to say. Oh yeah, if you're an African American, you should have more vitamin D. Our research is saying we should probably be thinking about that, because we can see we have evidence at the genomic level for how this receptor works as a transcription factor, that it seems to be behaving and functioning in a distinct and more prominent manner in African American prostate cancer cells than it is in European American prostate cancer. So that would suggest that it's more responsive to vitamin D. And certainly when we looked at tumors from prostate cancer patients, from African American men and European American men, the gene expression profile were much more responsive or reflective of the level of serum vitamin D in the patient in African Americans than it was in European Americans.
Well, first of all, where do people get most of their vitamin D from? Is it sun exposure? Is it the food they eat?
Yeah.
Is it just generated inside their body? Like what would modulate their vitamin D levels?
Yeah, the primary route for synthesizing vitamin D is sun exposure, and so exposure when you go outside, certainly in summer months, very very rapidly make serum vitamin D. Now, my ancestry is Scottish, and I am I'm pretty pale, and so if I obviously if I go outside, and I live in California now, if I go outside in summer months, I have to be very careful, because of course very quickly my skin responds to the sun, and I presumably make a lot of vitamin D, but I'm also going to burn it. And so our skin tone reflects our ancestral adaptation, and obviously we have we live in a world now where many people don't live in the environment that their ancestors had adapted to. And so skin adaptation is one very profound environmental adaptation that's occurred in our history of how we acclimatize to different environments. And I guess our research hints that, well, the adaptation to low, high sun exposure was not only loss of melanin content as humans migrated out of Africa, but perhaps it was also reduced prominence of how the vitamin D receptor signals in tissues in which it was critical.
Okay, so people that have more melanin in their skin, maybe darker skinned folks, how do they process and produce vitamin D with the same sun exposure as someone that's fairer skin?
Exactly. That so the darker skin and African Americans often in America, obviously in America, because they're African Americans, will have a greater risk of having lower serum vitamin D levels, and there's all sorts of levels of evidence for that. And so because of this reduced ability or higher melanin content, reducing the ability of given sunlight to make vitamin D.
Okay. I don't know, is there any administration of vitamin D, let's say through an IV, that would be helpful to people that are undergoing cancer at various stages? Like what would be the recommendation if someone has low serum levels?
Yeah.
I don't know how much investigation they would be needed to figure out why. Is it diet? Is it lack of sun exposure? Is it, they're just not able to produce vitamin D3 because they have a broken pathway?
I don't know.
Things that cause low levels?
I don't think we're saying it's a broken pathway. I think, obviously, I have to be careful with our choice of words here. And I think we're saying higher melanin content means that for a given unit of sun exposure, there's lower production of vitamin D. Now, the challenge is figuring out when's the point that you can either measure the impact of that or intervene. You're right. So, you could take vitamin D supplements and very quickly increase the level of vitamin D in a person's system. But where was the critical point in that person's, life when it was important to have sufficient vitamin D? So, for example, the guy in his, so I'm in my mid-50s, a guy in his mid-50s who goes to his doctor and he's got rising PSA level. Is it too late at that point to admit it, and we say, oh, look, he's vitamin D deficient. Is it too late at that point to even bother intervening with vitamin D? Honestly, I don't know. Would we have had to have done that intervention, during adolescence, or is it during, your 20s? Or, I think those are very open questions about how you take these sorts of, molecular studies and then try and translate them to human health approaches.
Okay. Are there other folks studying this, or do you feel like you're a lone wolf in the industry, or what?
I don't think I'm a lone wolf. I think, there are other people studying this. We're the first group to probably do it at this level of this genomic level. So, and we is again, I have a long-term partnership with a colleague and a friend called Clayton Yates. And one of the things that Clayton had done a few years back was to establish these cell models from African-American prostate cancer patients. So we were the first people to do what you call, ChIP-seq or stromic studies in European versus African-American cells of the vitamin D receptor. Just at the end of last year, someone did it for the Salma Kachar at Baylor did it for the androgen receptor in prostate cancer. And she showed that the androgen receptor was binding seemingly in distinct patterns in African-American versus European-American prostate cancer patients. As far as I'm aware, so far, that's the only two studies that have looked at transcription factor function in the context of health disparities at the level of where these transcription factors bind, across races. So, we're not though. So some of the things we did, yes, we were the first to do it. But obviously, what it's like with research. If you've had an idea, you can guarantee 1,000 other people have got the same idea. It's a collective effort, isn't it?
Yep, I got you. Quick question here about vitamin D. I've always heard about vitamin D3. Is that the only biologically available form, or what forms are necessary?
Yeah, so vitamin D3 is the active. So one alpha 25 dihydroxy vitamin D3 is the active ligand that then binds to this receptor and turns on genes. But there are, as with all kind of metabolic cascades in the body, there are precursors that are made, and some of those precursors form a kind of a pool from which the active one can be synthesized rapidly. So there are lots of different forms, but 125D3 is the active hormone.
Okay.
Now, and maybe that point about the active, the active one or the active, so there's pro-hormone, the active hormone, and which ones we should measure and how they all relate to whether it's bone health or prostate health. Those are, and in some ways, those are still quite areas of active investigation. And, it's not really an area I focus on, but I'm aware of, that people think very seriously about which one should we be studying and which ones are the critical ones, so certain the pro hormones buffering the active hormone and those sorts of questions.
Okay, well, very good. Murray, what's the best way for people to find out more about your work? Where can they go?
That's a good point. I guess, obviously, Cedars-Sinai, and then, the paper was published. So, that's publicly available. So, obviously, PubMed searches finds me. So, yeah, that's what I would say. And it was funded by the Department of Defense through their Prostate Cancer Health Disparities Program.
Okay. Well, very good. Well, Murray, thank you for coming on the podcast. I appreciate it.
Yeah, I'm really grateful. I hope I was able to answer your question.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.